Hello everyone, we're on question 12 now, and it's a nice sort of like modelling with trig question. So first of all, it says express 140 cos theta minus 480 sine theta in the form k cos theta add alpha. Okay, so this is quite a nice straightforward kind of thing, and the way that I like to do this, I know teachers have different approaches for this, but I like to do it by going to the formula booklet and looking at the appropriate addition formulae and then drawing my expression from there. So what I've done here is I've written, we're looking for cos of theta add alpha. So I've written it as k cos theta add alpha, and I've just copied this format here. So k cos theta cos alpha, and it's going to be, notice you have to be careful with cosine, that when you have a plus there, you have a minus here. So it's going to be minus k sine theta sine alpha. So that's how you begin this question, by just drawing that kind of comparison. Okay, so now that we've drawn that comparison, I now like to compare these two bits with these two bits. So let's compare these two. Well, we can see we've got cos theta and cos theta there. So that means that k cos alpha must be 140. So we can form an equation from that. Now let's compare these two. Sine theta there. So therefore k sine alpha is going to be 480. So we've got two equations that we formed. So now we divide those two equations by each other. So the k sine alpha divided by the k cos alpha. And when we do that, the k's cancel, and we get that tan alpha is going to equal 480 over 140. So 480 over 140 simplifies into 24 over 7. So inverse tan of that gives us our alpha. So alpha is equal to 73.74 when given to two decimal places. Okay, so we now know our alpha, so we go back to the two equations, and this time we square this equation and square this equation and add them together. And it's always the same approach. So I've got the first equation squared, the second equation squared, I add them together. So the reason we do this, by the way, is so we can take out a common factor of k squared, and we're cunningly left with cos squared add sine squared is 1. Okay, so therefore that just becomes 1. So we end up with k squared is equal to the two values that we got squared. So 140 squared add 480 squared is going to be 2, 5 and 4 zeros. Okay, whatever that is, 250,000, that's right. So therefore k is the root of the 250,000. So k is equal to 500. So now we've got our complete model, because we've worked out our a, our k and our alpha. So we found k is 500, and we found that alpha is 73.74 when given to two decimal places. So that's part A done for 3 marks. Now it says, now a scientist studies the number of rabbits and the number of foxes in a wood for 1 year. The number of rabbits R is modelled by the equation R is equal to that, where T months is the time after the start of the year and A is a constant. Given that during the year the maximum number of rabbits in the wood is 1,500, find a complete model for this equation. So the thing we need to do here is we always need to compare the thing that we found in the previous part of the question with this new thing that they've introduced. And actually, I have seen some quite fiendish ones over the years that have been, kind of like hard to figure out what the jump is, or at least I found them hard to figure out. But this one's really nice, because all they've done is they've just changed theta for 30t. So that's the only way in which this differs from this, okay? Or rather, let's have a look. I should say, we need to compare it. Actually, what I should be saying is we need to compare this over here, the 140 cos theta, with this part here. Now, first of all, notice the numbers are the same, 140, 480. 140, 480. So they've not multiplied it by anything, which is kind of nice. And then the other thing that's happened is the theta has changed into 30t. So the only thing that's happened in changing this expression that I'm indicating with the cursor now into this expression is it's just going to be that the theta gets replaced by 30t. So that's quite nice as this kind of question goes. They often in the past, in years gone by, have been much meaner than that, okay? So all we've got to do is write down exactly the same, but theta has been replaced by 30t. So that's quite nice, actually. So now we've got to find out what's going on with the maximum number of rabbits. The maximum number of rabbits is 1,500, the question tells us. So we've got the maximum number of rabbits is 1,500. Now that's going to occur, and this is the idea that when students first see this topic, they find this a little bit troublesome when they first see it. The maximum in this question will occur when this expression is 1, okay? Because you're going to have something add 500 times 1. The biggest that cosine can be is 1, okay? Because cos only goes between 1 and minus 1. So therefore, if we want the biggest that this cosine can be, the biggest it's going to be is 1, okay? So that's an idea that when students first see that, they can find a little bit difficult to get their head round. But it's going to be a maximum is going to occur when this is 1. So therefore, we have the 1,500 is A add 500. So that means that A must be 1,000, okay? So we've used that information that the maximum number of rabbits occurred when this was 1. So we've now got our complete model for the number of rabbits, and that is B part 1 done. B part 2, hence write down the minimum number of rabbits in the wood during the year according to the model. So the minimum number of rabbits, that's going to occur when this cosine function is minus 1. So we're going to have R is equal to 1,000 plus 500 times by minus 1, which is 1,000 take away 500. So therefore, that is going to be 500. So the minimum number of rabbits is 500. Okay, now, the next bit. So this question's been quite kind so far compared to how this question can be. This question can be very, very tricky. This question can sometimes be one of the hardest questions on the paper, depending on what they do with it, but this one's quite a nice version. So it says the actual number of rabbits in the wood is at its minimum value in the middle of April. Use this information to comment on the model for the number of rabbits. So let's have a think about that. Remember that the model is measured in months after the start of the year. So if we're in mid-April, we've had all of January, we've had all of February, we've had all of March, and we're halfway through April. We're 3.5 months into the year. So we're going to sub in t as 3.5 into our equation and see what that gives us. So when we sub in t as 3.5 into the equation for the number of rabbits, we find out that the model predicts that there is 500.1. Now actually, that is super close to the actual minimum number of rabbits. So this model is predicting what's going on really, really well. So we can say that this is a suitable model. It's a reliable model. You might be wondering, often students ask me, how accurate does it have to be in order to say that it's okay? And when I was marking a paper this year for Edexcel, the sort of like tolerance was like plus or minus 10%, okay? So if it's kind of like within 10% of the actual value, then that's when you would say that it's a good model. But normally they make it more obvious. They don't leave it ambiguous. They normally make it so that it's like way less than 10% out or way more than 10%. But the criteria that was given for marking for examiners was if it was like within plus or minus 10%, okay? And this one is clearly, way less than 10% because it's hardly anything out. So the model is reliable. Okay, last bit of this question now, what's going on with the foxes? So the number of foxes in the wood during the same year is modeled by that equation. Foxes equals 100 add 70 times by sine of 30t plus 70. The number of foxes is at a minimum value after t months. Find, according to the model, the number of rabbits in the wood at t months. So step 1, it's 4 marks as well. That's a lot of marks for this. So step 1 is we need to find out what's the value of t when the number of foxes is at its minimum. And the number of foxes will be at its minimum when this expression, our sine of 30t add 70, is equal to minus 1, okay? So we just need to solve 70 sine 30t plus 70 is equal to minus 1. Now, from the graph, I think drawing the graph is always the best way to go. I'm not a big fan of that cast diagram thingy-me-bob, whatever it is. So we're going to say, we're going to go from this sketch here. So we can see from my graph that the minimum occurs at 270 degrees. Okay, so that means that 30t add 70 is 270. Taking 70 off both sides, 30t is 200, dividing by 30. So t is 200 over 30, which is 20 over 3. So that's the value of t for which the number of foxes is at its minimum. And the question's asking, what's the number of rabbits at this time? So we just know to go back finally now to the rabbits equation and sub this value of t and see what we get. So when the number of foxes is at its minimum, the number of rabbits is going to be the equation for rabbits, but with t subbed in for 20 over 3. And when we work that out, it turns out to be 1032.61. So I've just rounded it down to 1032. However, the mark scheme indicates that they will accept 1033 as well. So either one of those is acceptable. And that's the end of that question. Now that, I have to say, is a very fair and very nice version of that question. If that came up in the exam like that, so if you're wondering, is that a hard one? That's a nice version of that question. That question can be much trickier than that, depending on how they're feeling on any particular year. But I hope you found that helpful, and I'll see you in the next video.